Hello, so today we're going to be taking a look at factoring trinomials where a, this leading coefficient here, does not equal 1. So it could equal anything other than 1. It could equal 5, it could equal 8, it could equal -1. Anything other than 1, we're going to use this method. Okay, so there's some examples on page 12 for you that you can take a look at on your own. But what I'm going to do is I'm going to just, in this little space on the bottom of the page, I'm going to make up an example for us to do. And that way we can try one out, and you can take a look at these other examples on your own. All right, so let's try this out. Let's write example. Do it right here, where we could fit it on the bottom. Okay, so we're going to take a look at 3x squared minus 2x minus 8. Now, when this leading coefficient is something other than 1, we do not set up two sets of parentheses. What we do instead is we take this first term and we just bring it down. Okay, then we're going to leave a big space because we're going to fill this in with other stuff in a minute, and then we take this last term and bring it down. So instead of bringing it straight down, I'm going to kind of bring it down over here because I need a little bit of room before it. Okay, so normally what we do is we come up with two numbers that add to -2 and multiply to -8, but when there's a number in front of your first term, when the leading coefficient is something other than 1, we are going to multiply together our first and our last terms. So 3 times -8 is -24. So this time, we're still going to come up with two numbers that add to this middle term, right, that add to -2, but instead they're going to multiply to the rainbow number, so it's going to multiply to -24. Okay, so off to the side, I made a list of numbers that multiply to +24. Now we know since it multiplies to -24, one of the pair of numbers has to be negative. So let's look. If it's going to add to a negative, add to -2, it means we have more negatives than positives. So that means our bigger number has to be negative. So let's put a negative next to the bigger number. Okay, now out of these pairs of numbers, which pair adds to -2? That's right, this one on the bottom here, +4 and -6. All right, so now I'm going to come back over here to my problem, and in this space that I left in between the first and last term, I'm going to put a +4 and a -6. And you could do it in whatever order you want. I'm actually going to put the -6 first and then the +4. You'll see why in a minute. Now, in addition to putting those two numbers in the middle, right, what we have to do is, see how this middle term has an x on it? We need to put an x on these two terms. Okay, and I just want to explain, the reason why we're allowed to go from here to here is because technically these two expressions are equivalent, right? I have the 3x squared, I have the -8, and if I did combine my like terms, isn't -6x and +4x and -2x? Okay, so these are equivalent. Okay, so now what we do is we do something called grouping. We group together our first two terms, and we group together our last two terms. Now, if you look at these first two terms, you want to say, well, what is the greatest common factor? What could I factor out of each of these two terms? So I could pull out a 3 as well as an x, right? 3 is the biggest number that divides evenly into 3 and 6. And I can also pull out an x because, look at this, we have two x's here being multiplied together and one here. So the most that you could pull out is one x because this only has one. Okay, now in parentheses, we're going to write what we're left with after we factor out a 3x. Now, factoring out is just like dividing each of these terms by 3x. So 3x squared divided by 3x would be 1x. Okay, 3 divided by 3 is 1. You could put the 1 here, but you don't have to. And x squared divided by x, right? This is really x to the first power. Just subtract the exponents when you divide. 2 minus 1 is 1. So leaves us with x to the first power. So we have 1x to the first power, which I'm just going to write as x. Okay, then I'm going to bring down my minus sign. And then 6x divided by 3x is just 2. Okay, then I look at my second set of numbers. I have a +4x and a -8. So really the only thing that I could divide or pull out of these two terms would be a 4. And since this first term starts with a positive sign, I'm going to factor out a +4. Okay, when you decide what sign to factor out, it's always whatever sign is in front of your first term here. All right, so if I pull out a 4, 4x divided by 4 is just x, and then bring down my minus sign, and 8 divided by 4 is 2. Now, at this point in the problem, you want to look and you want to say, do I have the same expression right there within the parentheses? Yes, I do, and that's important. You want to have that, right? These have to match up. If these match up, it means we're almost done. What you do is you take what's in front of the matching parentheses, so the 3x and the plus 4, and I'm going to just put an arrow for now. I don't usually put the arrow, but I'm going to put it for the first time. I'm going to take this 3x and the plus 4, and I'm going to group those together as my first factor. Okay, so I take what was in front of those common parentheses, the 3x and the plus 4, and that's how I get my first factor. Then I take this common parenthesis, the x minus 2, and I write that once and once only. I make that my second factor. Now, let me just explain how this is my final answer, by the way. Let me explain how this is equivalent to what we have up here. Okay, so think about this. If I were to multiply out this binomial, this factor, times this binomial factor, wouldn't I first distribute the 3x to both of these two terms? Right, so I'd first distribute the 3x to the x minus 2. And look at this. Technically, isn't this what this says? 3x times x minus 2? And then wouldn't I distribute the 4 to the x minus 2? And isn't that what this says here? 4 times x minus 2? So this is the expanded form of our answer. Okay, so these right here are our factors that multiply together to give us this original problem. So we're going to try another. These take a little bit of practice to get them down. So let's flip to the next page, and let's take a look at number 32. Okay, so we are on page 13. Now, if you take a look at number 32, we look and say, well, look, the leading coefficient is not a 1. And it's not like we could factor out that 7 out of all these terms. So the 7 we're stuck with there. So when that happens, remember, we do not set up two sets of parentheses. We bring down the first term, we leave a big space, and we bring down that last term. Okay, so bring down the first term, bring down the last term. Now we make a rainbow from the first number to the last number, and we just multiply those together. So 7 times negative 6 is negative 42. All right, so now we want to come up with two numbers that multiply to negative 42 and add to negative 19. So that might take a little bit of trial and error on your part, okay? You can do that off to the side. When you do, the two numbers that you get are negative 21 as well as positive 2. So I just want to explain that again. Negative 21 times 2 is negative 42. Okay, it's got to multiply to that rainbow number. And negative 21 plus 2 is negative 19. Now let's think about this. This doesn't just say negative 19, it says negative 19x. So since there's an x on that middle term, we need to put x's on these two terms. Okay, and now we can group. We group together the first two terms, and then we group together the last two terms. So you want to look here and say, what could I pull out of these two terms? Well, I could pull out a 7 as well as an x. So I'm pulling out a 7x. Then I'm going to put in parentheses what I'm left with after I pull out a 7x. Well, 7x squared divided by 7x is x. And if you wanted to check that, just multiply this together. Doesn't 7x times x give us 7x squared? Okay, now let's bring down the minus sign. 21x divided by 7 is just 3. And again, if you wanted to check it, distribute the 7x in. Isn't 7x times negative 3 negative 21x? Okay, so now let's look at our second pair of numbers. We have a positive 2x and a negative 6. Now, since this is a plus sign, we know we're factoring out a positive. And let's think about it. What's the biggest number that divides evenly into 2 and into 6? 2. Okay, so let's open up our parenthesis and write what we're left with after we factor out or divide out a 2. 2x divided by 2 is x. And then I'm going to bring this minus sign down. And 6 divided by 2 is 3. Or if you didn't bring down the minus sign, right, originally you could have just said, what's negative 6 divided by 2? Negative 3. Now, if you recall, look, we're on the right track because these x minus 3's match up. You should have the same thing within the parentheses, okay? So if we don't, we got to go back and try to find our mistake. Now, once these say the same thing in parentheses, don't we take what's in front of the parentheses? So there's 7x plus 2, and don't we make that our first factor? And then we take the common binomial factor. Okay, we take what we see in parentheses here, and we write that once and once only. Please don't write it twice. Remember, there's not actually two of them. This is the expanded form of these two factors being multiplied together. Okay, so this right here is our answer. All right, and if you flip to page 14, we're going to try one more together. Let's take a look at 35. So now number 35, when you look at this, what you may notice is we can first factor out a greatest common factor, right? Doesn't 3 divide evenly into all of these numbers? And if you can do that, you want to make sure you do that first, okay? You want to factor out a greatest common factor. Because if we forget to do that, our expression is not going to be fully factored. So if you recall, when we factor out a greatest common factor, we factor out what we can, and we set up one big parenthesis, and we put in this parenthesis what we're left with after we pull the GCF out of all three terms. Okay, so 36x to the 4th divided by 3 is 12x to the 4th. I'm going to do it like this time. Negative 33x squared divided by 3 is negative 11x squared. And then positive 6 divided by 3 is positive 2. Okay, so now this 3 is one of our factors. This 3 is just going to keep coming down and coming down. So let's bring that down right away so we don't forget. So our first factor is a 3. Now, if we look within these parentheses here, right, isn't our leading coefficient something other than a 1? So what that tells us we're going to have to do is we're going to have to do the rainbow with these two numbers. So let me open up parentheses. Let's bring down our first term of 12x to the 4th. This is the first term of our trinomial. Then I'm going to leave a big space, and then I'm going to bring down this last term. But I'm going to move it over so I give myself some room. Okay, so now we have to do our rainbow. So let's multiply together the first and the last term. And when I do that, 12 times 2 is 24. Okay, so I need to come up with two numbers that multiply to positive 24 and that add to negative 11. So negative 8 and negative 3. Okay, negative 8 times negative 3 gives us positive 24, and negative 8 plus negative 3 gives us negative 11. But look, since this term has an x squared on it this time, guess what I have to put here and here? That's right, an x squared. So whatever we have in that middle term, that's what we put on these two terms that we created. Because remember, if I were to combine these, they need to combine to give me what the original expression said. So negative 8x squared minus 3x squared is equal to negative 11x squared. Okay, so now from here, remember this 3 on the outside just keeps getting brought down. And now, within this big parenthesis, I'm going to make it big. We group together the first two terms, and we group together the last two. So out of these first two terms, it looks like the biggest number that divides evenly into these is 4. And then if we look at our x's, we want to basically take out whichever one has the smallest exponent, which is x squared. So I'm going to take out a 4x squared out of the first two terms. Then I'm going to open up another parenthesis, right? And we're going to put in that parenthesis what we're left with after we take out a 4x squared. So we're really just dividing. 12x to the 4th divided by 4x squared would be 3, and then x squared. When you divide, you subtract the exponents. So 4 minus 2 is 2. So it's x to the second power. So we get 3x to the second power. Okay, we're just dividing. Okay, and then negative 8x squared divided by positive 4x squared would just be negative 2. And I just want to point out, when you divide, right, doesn't this x squared cancel off with that x squared? So we have no x's left to put here. Okay, now let's look at these two terms. There's really nothing that we could take out of either term. But we do have to take out a negative sign, right, because that's what our leading coefficient starts with. And what are we really taking out? Negative what? A negative 1, right? When you can't pull something out, we just pull out a 1. But in this case, since this is a negative, we're taking out a negative 1. All right, and then let's open up a parenthesis. So negative 3x squared divided by negative 1 is positive 3x squared. And then 2 divided by negative 1 is negative 2. And then let's close that parenthesis. So what we have here is we have parentheses within this bigger parenthesis. All right, so this factor of the 3 comes down again. And now, if you notice, this says 3x squared minus 2, and this says 3x squared minus 2, so we know we're on the right track. So we're going to take what's in front of them, the 4x squared and the minus 1, and we're going to put that in our first parenthesis. And then we take that common binomial, the 3x squared minus 2, and we write that once and once only as our third factor, right? So right now we have 1, 2, 3 factors. But if you notice, I said right now, because look at this. I don't know if you noticed this, but here we have a difference, and this is a perfect square, and 1 is a perfect square. So this is a difference of perfect squares. So I'm actually going to factor this parenthesis further using dots. Okay, so the square root of 4x squared is 2x, so that's going to go in the first spot in each parenthesis. One of them gets an addition sign, the other gets a subtraction sign, and the square root of 1 is 1. So I'm going to put that in the second spot in each parenthesis. Now, don't forget to bring down this factor of a 3 and this factor, right? This doesn't factor further. This is a difference, but not perfect squares. So we're going to bring down our 3x squared minus 2. So in this case, we actually have 1, 2, 3, 4 factors. So this one we had to factor completely. We had to keep going and keep going. So this is our final answer.